and hey, what is this on my page? Woo, what's the what are you guys all doing? You're blocking our entire page here, you little dazzle of zebras. Well, which one of you are Zeke anyway? Oh, y'all look the same. You sure you're not like twins or triplets or who knows how many of you look the same? Why are you guys all on my page? Oh, really? Okay, that's good to know that that's how you stay safe. But no, I have not seen a lion around here. I have not. And, I'm kind of thinking that you're probably safe because look at you're in a big herd. So anyway, we gotta kind of get you off. I hope you don't mind. I'm gonna push this herd somewhere else. Okay, we gotta move you along because we have a method to do. Oh my goodness, you're down there too. My goodness, there's a lot of you. All right. Woo, wee. Okay, I don't know. I've been doing this job a really long time. I can't say I've seen anything like that. That's pretty bizarre. Pretty crazy. Okay. Cool, Zeke. Good to know that you're still, hanging out with your bros. But it's time for us to do math. That's right. We are here for another math video. Woohoo! Yes, and this is part 3 of chapter 5. Okay, and before I go on, let me just say, 4th graders rock. Yes, 4th graders, you guys rock, man. Woohoo! Now, it says Winnie wrote the following riddle. Oh, cool, I love riddles. I am a number between 60 and 100. My ones digit is 2 less than my tens digit. I am a prime number. Oh, I love it. And what does it say? What number does Winnie's riddle describe? Explain. All right. Well, let's just bring it on back to where we started. Basically, the first line is not too important for us. I am a number between 60 and 100. Okay. My ones digit is 2 less than my tens digit. So if this were the 1 and this were the tens, I could set it up this way. But it says that my 1 digit is 2 less. I'm just going to practice. If I put a number 2 in here, it has to be 2 less than the tens digit. So the tens digit could be 4. However, it can't be 42 because, Winnie said the number was between 60 and 100. Okay, so that was kind of like a sample. So one thing that we do know is we know that the number in the tens place has to be a 6, 7, 8, or 9. And it can't be 100. Okay, it's between those. But it could have a 6. So first things first. So I'm just going to put possible tens could be 6, 7, 8, or 9. Now, if we keep following what it says, if the ones place has to be 2 less than the tens digit, then that's also like saying the tens digit has to be 2 more than the ones digit. That means if we did have a 6, then the ones would have to be a 4. And if we did have a digit 7, then that would have to be a 5. You see the pattern already. 6 and then 7. Which means our numbers could be 64, our numbers could be 75, our numbers could be 86, or 97. But here's the thing. It says here, I am a prime number. And remember we learned about prime numbers? Exactly 2 factors. That's right. So 64, that's an even number. Okay, and an even number means, that it's going to have a factor of 2. You can take 64 divided by 2 and get a whole number, no remainder. And 32 would be, 32 times 2. So 64 is out of the running because it's not prime. And that's also true for 86 because that's also an even number, which means you could divide that number by 2. All even numbers can be, all even numbers are divisible by 2. They can be divided by 2. That only leaves these 2 left. If you look at 75, maybe you know your money pretty well. 25 plus 25 plus 25 is 75. That means you could take 25 times 3. And since we already know that it has 2 factors, 1 times 75, now you have 25 times 3. That is no longer a prime number. Yeah, that means 97. You're the winner. You lucky number. You're prime. Ho-ho! What number does Winnie's riddle describe? Explain. Well, I kind of said a lot of this here, but let me put it down in my notes here. There you go. Howdy doody time. Woohoo! Yeah. Okay, let's move on. Okay, now we have part B. It says Winnie's friend, Marco, guessed that her riddle was about the number 79. Why can't 79 be the answer to Winnie's riddle? Explain. Whew, okay. And it can't be 79, although 79 I believe is prime. So it's a prime number. But 79, if you look at the ones place, you can see that the ones place is 2 more than the tens place. And so it looks like that Marco, got the two numbers switched around. So I'll put it in those kind of words here. It's like the problem said that the ones place is 2 less than tens place. Marco reversed the numbers and made the ones place 2 more. Okay, there you go. That's kind of like what we said already. So yeah, he just switched it around. He just made the ones place, 2 more than the tens place when the problem said the tens place had to be 2 more, or the ones place had to be 2 less, is actually how it was phrased. Easy peasy, lemon squeezy. Okay, now we look at number 18. It says, classify the numbers as prime or composite. Okay, again, I've probably said this a million times. I know, but like a prime number is a number that has only 2 factors. Exactly 2 factors. In fact, woohoo, you notice that? In fact, factors? I like that. In fact, a prime number has to have exactly 2. So the number 1 is not prime. Sometimes students will think that the number 1 is prime, but it is not, because 1 actually only has 1 factor, because the 1 and the 1, it's the same number. So we say that it only has 1 factor. So 2, 3, 5, 7, those are all prime numbers. So when I look at it, this is where the divisibility rules are going to have to come into play. And the number that I could eliminate almost immediately and say that it's not prime, for the 82, well, it's an even number. We just talked about it. And all even numbers you can divide by 2. Okay? That one's going to equal 41. That means it has more than 2 factors, so we know that the 82 has to go here. There's probably more. I'm just going to put that there. 65 is another easy one to find that's not prime because it ends in a 5. And a 5 will always go to a number that ends in 5 or 0. Remember, that was the divisibility rule. 13. I think that's 13 times 5, 15, 65. Okay? So that's going to equal 13. Not that all this matters. Ooh, it's kind of really messy. Ooh, that's a cool design. Okay, anyway, so that one's going to come over here. Now, 71 and 37. They look prime to me. And I say look prime. 37 is definitely prime. And the reason that is a 2 won't go in there. A 3, if you add up the digits 3 plus 7, that's 10. 10 is not divisible by 3, so 3 won't go in there. 4 times 10 is 40, but 4 times 9 is 36, so that doesn't work. So all I'm doing is go up. 5 doesn't end in 5 or 0, but with 6, it includes 2 and 3. So if the number is divisible by 2 and the number is divisible by 3, then and only then is it divisible by 6. So that didn't fit. And 7 times 5 is 35. 7 times 8, no, it's going to go right on by. So yeah, I'm saying that's prime. And 71 is another one of those numbers just look prime. Even if you add them together, you get 8. 8 is not divisible by 3. It's not divisible by 2. 4, no, that's got to be prime. And the only way you could do that if you wanted to is you could do your skip counting. 4, 8, 12. If you didn't know how else to do it, you could take 71 divided by 4. If you're wondering, like, how do you know, Mr. Wara? That's probably what I would do if the number I really didn't know. 4 goes into 7 one time. You get 3 left over. Bring down your 1. 4, look at that. It's not going to go in there evenly. So that lets you know right away. Yeah, it definitely, 4 won't go in there, and a 5 won't. 6. Yeah, pretty soon when you start getting the number up to about 7, 8, or 9, yeah, it doesn't look good. All right? So that's my final answer. 37, 71 prime, 82, 65 composite. Okay, let's keep cruising on. Hey, where'd you come from? Hey, make it really, man, I'm getting sloppier. Okay, Erica knits 18 squares on Monday. Okay, she knits 7 more squares each day from Tuesday through Thursday. How many squares does Erica knit on Friday? So it's kind of like a pattern deal, huh? Well, we have 18 that she did on Monday, and then she did just 7 more. That's interesting. She got a really head start. Monday she worked hard. 7 more squares each day from Tuesday through Thursday. 7 more squares. So then I'm seeing a pattern, right? So that's going to come into 25. And it says 7 more. So that's now Tuesday. So now we're going to go to Wednesday. That's going to be 32, 39. So here we have Monday, Tuesday, Wednesday. Oh, that's Thursday. And then she's going to do all the way through Thursday. So that's going to actually equal 46. Oh, that's for Friday. Thursday was 39. So how many squares does, so I'm assuming this pattern is going to continue. How many squares does Erica knit on Friday? Yeah, so there you go, 46. It's just, it's like that add rule. The add 7 rule, okay? And this is what this is. Look, yeah, there it is, number 20. Use the rule to write the first 5 terms of the pattern. Okay, and it says first term. Remember what term is. This is just a term. 18 is a term, 25 is a term. If you were to have 4 plus 7, 4 is a term, 7 is a term. Okay, that's that. I like that they use this language because you'll be using it a lot in algebra in the years to come. Woohoo! Now we have 11. It says I have to add 10. This is the rule. It kind of goes add 10, and then I subtract 5. Add 10, subtract 5. Assuming that's what they're trying to say here. So add 10 gives me 21. Okay, because I've added 10. Oops, kind of sloppy. Okay, and I'm going to subtract 5, so that's 16. Subtracting 5. I'm going to go back to the add 10. So I subtracted 5 here. I need to add 10. That's 26. Adding 10 here. 5 for, okay, there's 4 terms. I need to do one more. And so I'm going to subtract 5. So I'm going to get 21. Well, I brought me back to that term again. Added 10, 26. Yep, well, it makes sense for me for following my little pattern. Okay, it's time for Page Master. Boo! Whoa! Whoa, you freaked me out. What? You gotta be kidding me. No. I am not helping you find a dazzle or a zeal, whatever you call the little group of zebras. Why am I going to help you? Oh, well, isn't that nice? The circle of life. Yes, it's the circle of life, but you know what? One of those zebras happens to be my friend. His name's Zeke. Yeah, you better leave him alone, buddy. All right? Time for you to skedaddle. Imagine that. Okay, well, maybe those guys are right. There was a line out there after them. Whew, good thing they were in their little group, in their little dazzle. Look at, there's a dazzle of zebras. Yes. Back to math, Mr. Warren. Yes. Alina had 10 tiles to arrange in a rectangular design. She drew a model of the rectangles she could make with the 10 tiles. So she had 10 tiles. Looks like she made one design. Cool. Just put them like in a big, long tower. I see that. Okay. And then I see, oh, this one, she kind of like doubled it up. So 2 across and 5 down. And there's 10 tiles for each one of them. I agree. Okay. So let's come down to part A. So part A says, how does Alina's drawing show that the number 10 is a composite number? Okay. I love it. Well, first of all, we know that a composite number, remember, has 3 or more factors. Okay? That's what makes a composite number. And there's a lot of them. Okay? A lot more composite numbers than there are prime numbers in the world, right? Because you can have numbers end in 2, you've got 3 being multiplied by a number to give you, so there's a lot of composite numbers. But in this case here, we have 2. The one array there, we have 1. Remember arrays? We have an array here, and so 1 times 10 is 10. So that's a factor, 1, that's a factor. But then we also have 2 times 5, which is also equal to 10, and 2 is a factor, and 5 is a factor. So 10 has 4 factors. 1, 2, 5, 10. How did her drawing show that? She showed it because she did that array, that 1 times 10 here, and then the 2 times 5. So that's how her drawing showed that 10 is a composite number. Also, if it wasn't a composite number, you wouldn't be able to make 2 different rectangles. You know, that's key right there. So the fact that we made 2 rectangles lets you know that the number has to be composite. So let's write those notes down. There you go. I did one of my poof. It just appeared. Like, hey, Mr. Warren, how'd you do that? Poof. All right. So that was part A. That's what we talked about. Obviously, there's more than one way that you could explain that. It dawned on me as I was starting to solve. If you can draw more than one rectangle, then it must be a composite number. Okay. Okie dokie. Let's keep on cruising. Suppose Alina used 15 tiles to make the rectangular design. How many different rectangles could she make with the 15 tiles? Write a list or draw a picture to show the number and dimensions of rectangles she could make. Okay, I might do a little bit of both here. Let's just see here. So the thing that is interesting is it's important to be able to find the factors of a number. And we know that if you have a factor, if you multiply with another factor, it gives you something called the product. And since here we're talking about we have 15 tiles. So we're basically trying to find out all the possible ways or numbers that you could multiply to get 15. And we know that the obvious one is the identity property, right, of multiplication, where, well, there's more, because we also know that there's 3 times 5, and that also will give you 15. We can't do 2, 4, so this is it. So we say that 15 has 4 factors, exactly like 10 up above. Now here I got an option here. So this is, you can write a list or draw a picture. Well, obviously, if you're going to draw a picture, and we're doing the rectangular model, you could have 5 on one side, and then like have 3 on the other. So if I made that the 2, 3, 4, 5, trying to do 5 this way, then if I were to just draw 3, I'm trying to make this as even as I possibly can. And it's still a rectangular model, but what I'm trying to do is show you where the lines are so you can see. So that way, 3 by 5, okay? And of course, 1 by 15 would be really easy, right? Oh, it's so sloppy. Okay, and you'd have 15. Like it? Beautiful? Yes, it's gorgeous. We're going to say then, write a list. Okay, so the list is the number and show the number and dimensions of the rectangles you could. So we could, oh, that's so sloppy. Let me fix that. Much better. I cleaned up my other mess there too. Come back over here, draw the line. Thank you. Okay. Let me go slower. We could, so you want to write slower? It's neater. We could make what happened to my N? One rectangular, barely got that one in there, design with a dimension. And don't think this is the only way that you have to answer this particular question. There's probably an easy way to write this too. With a dimension of 1, and I can put times or by, which does mean the same, by 15, and another design, leave out that rectangular, save the writing, another design of 3 by 5. I know, I'm just adding on, I know there are exactly 2 figures based on factors of 15. I'm totally putting a lot on here, okay? Don't ask me why, I'm going overboard. 1 times 15 is 15, and 3 times 5 is 15. Get the gist there. Yeah. Okay, guys, these are kind of easy. You know what? I thought the ones on the review 2 were a little bit more challenging. These are kind of easy. Hey, whatever happened to Zeke? You notice he's like always on the pages. It's just like he completely just disappeared. I don't know. Pretty bizarre. Okay, his little herd or whatever, his dazzle. Can't get that out of my head now. Alina's friend Luke said that he could make more rectangles with 24 tiles than with Alina's 10 tiles. Do you agree with Luke? Explain. Okay, a little bit more challenging, but not much. So the challenge here is basically the 24 tiles, okay, and Alina has 10. So obviously, Luke has more. Both numbers are even, so that's going to let you know right away that, well, they definitely both are divisible by 2, but 24 has more, like you probably know, because 6 times 4 is 24, but it also has 8 times 3. Oh, it has a bunch. So 24 is not only a composite number, but it's a composite number with a lot of factors. There's a lot of way to get 24. In fact, you guys are probably shouting out, 2 times 12, 2 times 12. That's right. That's another one. Of course, 1 and 24. I'm going to say I do not. Oh, wait. What's the question? Alina's friend Luke said he could make more rectangles with 24 tiles. And Alina, do you agree? Yes, I do. I agree with Luke. Because, you have to always say that because part. If you're explaining, it's important. I don't know how your teacher grades your tests when you get these tests, but I can tell you how I would grade. You always get like 1 point for the correct answer. It's important to have precision and accuracy and get the correct answer. But you know what? That's not enough because, you could use a calculator. There's so many different ways. So I only give 1 point for that. The explain could be anywhere from 2 points to like 3 points, depending on how well you explain. So it's really important that we show our understanding. And in your case, since you're a 4th grader, yeah, you have to show your teacher that you do understand. So I agree with Luke because 24 has more factors than 10. I can't say it's because it's a composite number because 10 is composite too. But 10 only has 4 factors. Look at 24 has, let me see here, is that all of them we listed? So we have 2, 4, 6, 8. So it has 8 factors. It's double. So let me finish this thought. I agree with Luke because 24 has more factors than 10. Therefore, I always like that word. Therefore, that's a great transition word to use in your writing. Makes you sound all scientific. Therefore, anyone can see when these two substances come in contact that there will be a chemical reaction. Yeah, it makes you sound really smart, right? Okay, 24 tiles will make, and you can tell by the figures. Here's one design, two designs, three designs, and the last one, four designs. We'll make four rectangular designs. Rectangular compared to, oops, I'm going to make that a C. Compared to, it shouldn't be a capital letter, okay? Compared to the two designs from 10. Okay, I didn't have to write all that extra stuff down there, but you get the idea. If any student wrote this, oh my goodness, it would be like max points, right? It'd be like, whoa, awesome. You're explaining completely. You're making it really easy for other people to understand. So, what? Is that it? Oh my goodness. I heard music. No way! Is this really over? You mean there's not another page? Oh my goodness, it doesn't seem right. But oh! Hey! You guys are hiding on my page! How'd you get in there? Yeah? Okay, yeah. Okay, you're all talking to me at once here. Chill, my friends, chill. Okay, where's Zeke? He's the person I want to talk. There you are. Sorry.
I kind of didn't know where he was.
Okay, I see you, Zeke. What's going on? Hey, I thought you were going to do your little interview thing that you talked about last time. You don't want to do that now? Well, then, what's up? You're going to make it hard for kids to ask questions? That's a lot of zebras. It's going to be really confusing. Yeah, that might be a good idea. Okay. Say goodbye to your friends. Later, dudes. Oh, there he is. I love it. Woo, let's take a safari. Okay. So, now look, Zeke, I've never done this before. I have a couple of students I know that said they want to ask you a question, so let's just kind of see how you do. All right? All right. Okay, cool. I'm glad you're excited. Very, very, very cool. Yes, fourth graders do rock. I agree with you. Okay, so the first question actually comes from George, okay, from a school, Fairview Elementary School in Pittsburgh, Pennsylvania. Ooh, it's a long ways away. For me, anyway. So he asked this question. It's a pretty important question. He asked, since now we know you're really just black with white stripes, although we look at you and think of you as being white with black stripes, why do you have stripes? Do they have any purpose? Oh, okay. Yes, they're unique. Really? Are you kidding me? Zeke, are you making that up? No? Oh my goodness, I had no idea. Did you know that? I didn't know that kind of acts as a good bug repellent. How bizarre. Oh my goodness. Zeke, you are educating us, my friend. Okay, cool. Well, we move on to, this question is actually from Natalie, okay, from Little Turtle Elementary School in Columbia City, Indiana. Wow, oof, okay, very cool. That's the Midwest. She asked this question. How do you avoid your predators if you don't have a herd? Can you run very fast? How do you stay away from the lions? Good question, Natalie. Yeah. Oh, wow. Cool. You can run up to 40 miles an hour. That's pretty fast. Man, that's moving. Oh, really? Huh. I didn't know you guys knew how to do that. Wow. Everything about you is like zigzag, looking at your stripes and everything else. Like, wow. Pretty cool. Very awesome. All right. Well, hey, Zeke, you know what? Hey, you're famous, my friend, okay? You got your dream come true. I'm glad you got rid of the contacts. That was a good move on your part. Your eyes are just fine how they are, my friend. Hey, you got to go. The kids are waiting. The music's starting to jam again in the background. My friends, we'll see you soon. Now.
Live long and prosper.